Hello and welcome. I am Dr. Pauline Fu. In this video, I will present hypothesis test for a population mean. So I will start off by reviewing what I did in the last two lectures about hypothesis test. Remember, hypothesis, it is just a statement or a claim. It is in the format of null hypothesis. H0 means no change. Okay, so for example, population proportion P equal to 0.32. Alternative hypothesis is H1. It is usually either not equal or smaller or greater. When you have H1 is not equal, it is a two-tailed test. You have left tail area and right tail area. When you have H1 smaller than, it is a left tail test. And when you have a greater sign, it is right tail test. Okay. And when you test hypothesis, you may have a chance to make mistakes. Those mistakes are type 1 error and type 2 errors. Okay. Type 1 error is the one you said you reject null hypothesis. As a matter of fact, the null hypothesis is correct. That is type 1 error. Type 2 error, you do not reject null hypothesis. As a matter of fact, null hypothesis is wrong, or alternative hypothesis is correct. You are making type 2 error. Okay. In terms of the method for testing a claim, usually we have two methods. One, classical approach. You have 5 steps. Usually this is the step 1, list the null and alternative hypothesis. And step 2, you specify alpha. Alpha has popular choices of 0.05, 0.01, and 0.1. And step 3, you calculate test statistic. Test statistic, it is just a formula. Okay. Depending it is a test about population proportion or a mean or a standard deviation. You have different formula. That means you have a different test statistic. And step 4, you found the critical value. Found the critical value. And step 5, you draw conclusion. And how do you draw conclusion? You compare step 3 with step 4. Okay. Remember in step 3, you get the critical value. Critical value decide rejection region. So those tails are the rejection region. If the result of your step 4, your test statistic is inside the rejection region, you reject H0. If your test statistic is not in the rejection region, you fail to reject H0. Okay. So those are the 5 steps. Classical approach to conduct a hypothesis test. Next, popular method is to use the p-value method. For p-value method, the first 3 steps remain the same. The step 4 is different. Instead of calculate critical value, you calculate p-value. And what is p-value? P-value is the area corresponding to test statistic. Okay. So if you have two-tailed test and you calculate it, this is your test statistic, this point. Remember, test statistic is a result of formula. Okay, because you have two-tailed test, you must have another point here, symmetry. So what is the p-value? P-value is the area corresponding to test statistic. So this area plus this area, that is your p-value. Okay, and this, suppose this point is the test statistic. Okay, test statistic. So this is two-tailed test. When you have one-tailed test, the p-value is just the little tail area, the area on the little tail. Okay. And once you calculated p-value, you compare p-value with alpha. When p-value smaller than alpha, you reject H0. Okay, reject H0. And when p-value greater than alpha, you fail to reject. You do not reject. Okay, do not reject H0. So that is the p-value approach. Okay. So this lecture, I will conduct hypothesis test about the population mean. Okay. By the end of this lecture, you would be able to use two approaches to do hypothesis test for population mean. One is a classical approach, compare critical value with your test statistic. The other is a p-value approach, compare p-value with alpha. Okay. And I will also talk about the statistical significance and the practical significance. When you do the hypothesis test, you need to calculate the test statistic. Test statistic is just a formula, okay? And so we need to introduce the formula, but before that, we need to introduce student distribution. Student distribution. Imagine you have a random sample and you can calculate the sample mean. We use X bar represent sample mean. And when you do a hypothesis test, you always targeting population. You assume a number for population mean, and this assumed number could be from historical data or from previous research. Okay, for example, the average age at Brock University may be 22 years old. Okay, so that is the population mean. Okay, and you randomly selected a sample of 30 students. You found the average age is 21. Okay, so X bar is 21, mu is 22. Now, you want to ask if this 21 significant or not significant. Okay. So anyway, once you have a sample, you can calculate the sample mean X bar. You can also calculate sample standard deviation S, sample standard deviation, okay? And N is the sample size, okay? And you do many samples that forms student T distribution with N-1 degree of freedom. N represents sample size. Okay. There are some properties for the T distribution. The first one, if you have different degree of freedom, you will have different T distribution. Okay. And the second one, T distribution is centered at 0, and it is approximately symmetric about 0. So this looks like a T distribution centered at 0. Okay. Property 3, the area under the curve is 1. If this is T distribution, all the area under the curve, that is 1. This area is 1. Okay, because of the center is 0. Center is 0. Okay, half of the curve, this size is 0.5. Okay, the area is 0.5. And this area is also 0.5, the other half. So this is the third property. Hey, Novi, go away. My little doggy is bugging me. The fourth property, when t increases, the graph approaches but never equal to 0. So when t increases, it is the graph approach, it is increased, but the graph will never touch 0. Okay. And the property 5, the area in the tails of a t distribution is a little greater than the area in the tails of standard normal distribution, because using sample standard deviation S, as an estimator of population standard deviation sigma. Okay. Introduce more variability to the t statistic. Okay. And the property 6, as the sample size increase, the density curve gets closer to the standard density curve. This result occurs because as the sample size increase, the value of sample standard deviation S get closer to the value of population standard deviation sigma. This is because of the law of large numbers. So those are the properties of student distribution or t distribution. The steps when we do the hypothesis test about a population mean usually involved in the following steps. First, we obtain a simple random sample. And we want to make sure the sample has no outliers. And the population is normally distributed, or you have a large sample size. When you have sample size greater than 30, we say that is the large sample size. Sample values are independent of each other. Okay, so those are the roadmap for conducting a hypothesis test for a population mean. In step 1, you always state no hypothesis and alternative hypothesis. There are 3 situations, depending on it is a two-tailed test, or one-tailed test, or a left-tailed test, or right-tailed test. When you have two-tailed test, H0 is population mean mu equal to, for example, 23 years old. Okay, so mu0 is 23. And alternative is the population mean mu not equal to mu0. For example, mu0 is 23. And when you have a left tail test, how do you know you have left tail test? Usually you have keyword decrease less than. Okay, so that decrease less than is reflected by H1. See H1 using smaller sign. Smaller sign signifies this is a left-tailed test. Okay. And right-tailed test signified by H1 has a greater sign. How do you know when do you use greater sign? Usually the problem has the indication. For example, increase more than, okay, that is greater than in H1 position. Regardless 3 situations, H0 always maintain equal sign. H0 always maintain equal sign. H1 could be not equal, smaller than, or greater than. Step 2, we select level of significant alpha, 0.05 or 0.01 or 0.1. Step 3, calculate test statistic T. We sometimes simply use T to omit the subscript T0. Okay, and the T statistic equal to sample mean X bar minus hypothesized population mean mu0. Divide standard deviation for sample S over square root of sample size. So this is step 3, calculate test statistic. Okay. Step 4, when you use classical approach, we need to calculate critical value. Okay. So if it is two-tailed test, and those are the critical value. How do you know the critical value? You can find critical value based on T table or using the Excel. So I will give you detailed in calculation as we progress through this lecture. When you have left tail test and the critical value is negative T alpha, critical value decide critical region. So this is a critical region. Critical region has another name, rejection region. Okay, rejection region. If test statistic is in the rejection region, you reject H0. So if you have right tail test, and suppose this is your critical value, and then you need to locate where is your test statistic. If your test statistic is here, is less than critical value, you do not reject H0. If your test statistic is greater than critical value, you reject H0. So this is the criteria to compare test statistic with critical value. When you have two-tailed, remember T0 is the test statistic. If test statistic smaller than negative critical value, or test statistic is greater than critical value, reject null hypothesis. And if you have left-tailed test, if test statistic T0 smaller than the critical value, because it is left tail, critical value must be negative. If test statistic smaller than critical value, reject null hypothesis. And right tail, if critical value greater than, or if test statistics greater than critical value, reject null hypothesis. Okay. So this is a classical approach, compare critical value with the test statistic. Next is the p-value approach. When you use p-value, the first 3 steps are the same as when you use critical value. So when you do the step 3, calculated test statistic, you found the p-value based on test statistics. Remember what is p-value? P-value is the area corresponding to test statistic. So If you have two-tailed test and you calculated, this is the test statistics. So what is the p-value? P-value is the area corresponding to test statistics. So this right tail area plus this left tail area, that is the p-value. Because of the symmetry, we sometimes also just multiply 2 multiply this right tail area, or 2 multiply this left tail area to get the p-value. And when you have left tail test, the test statistic is negative. And the p-value is this left tail area. This is the p-value. And similarly, when you have right tail test, P0 represents test statistic. The right tail area is the p-value. Okay. Sometimes technology can also help you to find the p-value. Okay. I will show you how to use Excel to find the p-value later. Okay. Once you get the p-value, you compare p-value with alpha. When p-value is smaller than alpha, you reject at 0. And when p-value greater than alpha, you do not reject at 0, or you fail to reject at 0. Step 5 is conclusion. This procedure is robust. Which procedure? The t-test for population proportion. Robust means minor departures from normality will not adversely affect the results of the test. However, it is strongly advised that when you have small sample size, or if you have the outliers, the procedure should not be used. Example. Assuming the resting metabolic rate, RMR, of healthy males in complete silence is 5,710 kcal per day. Researchers measured RMR of 45 healthy males who were listening to the calm music and found their mean RMR to be 5,708.07 with a standard deviation of 992.05. At 0.05 level of significance, is there evidence to conclude that the mean RMR of males listening to calm classical music is different than 5,710? Okay. So that is the question. Before we do the hypothesis test, let's analyze the given numbers. This number is a population mean, okay, mu0. Hypothesized a population mean mu0. And the 45 sample size n, 5,708.7 sample mean x bar, 992.05 sample standard deviation s. Okay. Now 5 steps. Okay. Step 1, state null hypothesis and alternative hypothesis. The alternative hypothesis is not equal. Not equal is the indicator. This is a two-tailed test. And how do you know this is two-tailed test? Sometimes the keyword different indicate it is two-tailed test. If the keyword is greater than, that is a right-tailed test. And if the keyword is smaller than, that is a left-tailed test. So step 2, specify alpha. 0.05. Okay. And step 3, calculate test statistic T. Okay. Remember the formula said X bar minus mu over sample standard deviation S over square root of sample size. Okay. And you get negative 0.013. This is your test statistic. Okay. The fact that you get negative is because the sample mean smaller than population mean. That's why you get negative. If sample mean greater than population mean, you should get positive test statistic. So once we did the first 3 steps, we use a classical approach to find the critical value. Okay, so we need to find critical value. How do we find the critical value? You need 2 items to find the critical value for T. One is degree of freedom, sample size minus 1. So 45 minus 1 equal to 44. Okay. And the other is the area. Okay. The area, when you have a two-tailed test, you use half alpha. Okay, when you have two-tailed test. When alpha is 0.05, half alpha 0.025. Okay, so I will draw a diagram here. What we are doing now, we are trying to find the critical value. Okay, and because this is two-tailed test, you should have 2 critical values. Okay, 2 critical values. One critical value is this point, and this area is half alpha. So this point is T, subscript half alpha. Because of the symmetry, the left tail area is also half alpha. And this critical value, negative T, subscript half alpha. Okay. So how do we know the critical value? How do I find out? You can go to the T table. But there is a convenient way to find the critical value in Excel. Okay, so Excel is everywhere. The table, you have to carry the table with you, or you have to have textbook to look up in the table. Excel, you can find anywhere. Okay, so I'm going to pull out my Excel. Okay. So in Excel, maybe I will delete those unnecessary numbers. In Excel, you are the formula is equal T means T distribution, dot INV means critical value. INV is inverse of T distribution. Okay. And then this is two-tailed test, .2t. This is a two-tailed test. The probability, typing, because this is a two-tailed test, you already tell it is two-tailed test. So